We're at the demo site for the Oklahoma Meson. Here in Oklahoma, we get all kinds of weather. I think weather is very interesting, especially tornadoes. I like weather so much that I have a home weather station. It displays current conditions and stores data. It's really cool, but I wanted to see how the professional weather folks do it. So the Oklahoma Mesonet invited us out to see their demo station on the University of Oklahoma campus in Norman. Before we go over to the demo tower, let's talk about what a Mesonet is and how it came to be. In 1984, floods in Tulsa killed 14 people. This loss of life fueled a man named Dr. Ken Crawford to build a better system for collecting and sharing weather data. Around that same time, an ag engineering professor at OSU, Dr. Ron Illett, was seeking for better weather data for crop research. Two men crossed paths and realized that they both wanted the same thing. They teamed up and began designing weather tower collection sites and worked to fund the project. Their efforts were successful, and on January 1st, 1994, the Mesonet was officially online. There are 120 data collection sites, with at least one site in each of the 77 counties in Oklahoma. The Oklahoma Mesonet is the world's first statewide permanent mesoscale observation network. It is considered the gold standard of Mesonet systems. What is a Mesonet? Meso comes from the term mesoscale, which refers to weather events that can span from 1 to 150 miles. Net comes from network. So the Mesonet is a network of weather data collection towers spaced out over the entire state and allows weather conditions to be accurately captured. Each of the 120 collection sites has a standardized setup. The demo site we visited has a few minor differences and is also used to test equipment, but the setup is almost identical to the 120 official sites. Let's take a look at the tower setup. The tower itself is 10 meters tall and is located in the center of a 10 meter by 10 meter square. The highest point is a lightning rod mounted to the top. This helps protect the sensors from lightning damage by providing a better path for the electric discharge to flow to earth ground. At the top of the tower is an anemometer. It measures wind speed and direction at the 10-meter height. There is a second wind speed sensor at the 2-meter height. Wind speed slows down the closer you are to the ground because of friction, so the 2-meter height speed will be slower than the 10-meter speed. Air temperature measurements are also taken at two heights. One sensor is at 9 meters and the other is at 1.5 meters. Having air temperature measurements at different heights better describes the weather for row crops like corn and taller crops such as pecan trees. There is also a sensor for humidity, which measures how much moisture is in the air. For accurate reasons, both the temperature and the humidity sensors need moving air. Stagnant air would distort the readings. Air hitting the sensors kept fresh, either by housing design or by a powered fan in the sensor head. There is a sensor for solar radiation, which is how much energy is being received from the sun. There is a sensor for air pressure. Changes in the air pressure helps forecast weather. For instance, falling pressure can mean rain chances are increasing. There are also sensors not on the tower.
A circle of bare soil is maintained, and at a 10-centimeter depth, soil temperature and moisture is measured. On the other side of the tower, the soil is covered with vegetation, and soil temperature and moisture are measured at depths of 5, 10, 25, and 60 centimeters. Finally, rainfall is measured by these two rain collectors. There are two of them because the rain measurements are so important. If one fails, the other can still be collecting data until a technician can repair the non-functioning one. The ring around the rain collectors is called an altar shield. The slats block updrafts from forming and reduce wind effects that can make the rain miss the gauge. It also squeaks and rattles a lot, which has the side benefit of deterring birds. Without that, the birds think the collectors are the perfect place to build a nest. Solar panels and batteries power the weather collection site. This includes power for all of the sensors, but also the data collector they are tied to. It also powers the cellular link and/or radio that transmits data back to the Mesonet headquarters every 5 minutes. If there are any transmission problems, that data isn't lost. The data collector keeps it stored until communications are restored. When the data is received, it goes through quality checks before being released. Much of this is automated by making sure readings are within expected bounds and in line with neighboring sites. In addition to that, data undergoes monthly manual reviews. Usually the data is made available within 5 minutes of being received from the tower. Towers are in service 24 hours a day, every day of the year, so the flow of data is constant. If the weather station detects potentially dangerous conditions, an automated alert is sent to the National Weather Service so they can quickly respond. For example, high wind gust would trigger one of those automated alerts. Every sensor has a unique code that tracks its use throughout the entire time it's in the system. With the code, you can look up when it entered service, when it was calibrated, what stations it has been active on, and when it has undergone any repairs. Every site is visited by a tech at least 3 times a year, and more often if there are problems. There are 3 techs on staff that perform the routine checks and repairs when something fails. A 4th tech on staff provides vegetation management for every site.
Now that we know what data is collected and how, let's discuss why.
Weather is important to all of us. We all use it for planning our days and making decisions like what to wear, when to water our lawns, and when to be on alert for severe weather. The data collected by the Mesonet helps with all of that and much more. Here are just a few examples of how this data is used.
Reporting on current conditions.
Weather forecast.
Severe weather alerts.
Emergency management.
Wildfire risk assessment.
Determining ideal conditions for prescribed burning.
Educational tools for schools.
Cattle Comfort Index.
Irrigation planning.
Applicator Drift Risk Advisor.
Heat units for growing crops.
Evapotranspiration.
And climate surveys and research. When you are watching Oklahoma weather reports on the current temperatures, those temperatures are being reported by the Mesonet. A little over a month ago, we planted some cotton. Farmers track heat units because cotton needs enough hot weather to grow properly.
So if we wanted to see the heat units the cotton we planted has received, we would go to the mesonet.org and pick the agriculture maps. Then select Degree Day Heat Units. We would pick the site closest to our field, in this case, Hobart, pick cotton as our crop, and enter the date the cotton came up.
This would give us a chart that shows how many heat units we got each day, and the total heat units so far.
If the field had an irrigation system, we could also use their irrigation planner tool to help us decide when and how much to irrigate. Commercial uses don't just include agriculture. Electric companies have staff meteorologists that can use the data to help them make forecasts that can be used to manage resources during weather events. For instance, the data can help make decisions on where to stage linemen and trucks in anticipation of downed power lines.
Teachers can also use the Mesonet in their classrooms. This includes looking at the data and utilizing materials developed by the Mesonet. There are worksheets, camps, job shadowing, guest speaker programs, and other resources. This map shows the number of tornadoes in each Oklahoma county in the last 70 years by color coding it. I see where tornadoes are more common and get to practice my graph and mapping skills.
Not only does the Oklahoma Mesonet collect the data, maintain weather tower sites, and publish the data, they also educate users on how to access and utilize the system. That means they train emergency managers, teachers, meteorologists, researchers, farmers, ranchers, wildlife managers, foresters, students, and others on how best to use the many tools they offer.
The Mesonet works to help us be safer, more comfortable, more productive, and better understand and predict weather. Thanks, Oklahoma Mesonet.